much easier than the hard way. It's unfair.
Okay, so we're going to try to learn inverses, which apparently Donald thinks is the easy one. My calculator can do this. My calculator can do A inverse equals go, and
Mine can't.
Oh.
I have to set up the
Okay.
the thing.
So, to calculate the inverse of a matrix, the first thing I should think is the determinant has to be non-zero. Cool? If the determinant is 0, do not waste your time trying to do this. You will get something funky. Don't worry, we'll fiddle with one in a minute so we can see what funky thing happens. Okay? But for right now, here's the idea. I'm going to do this by example. So, find 1, 2, 3, 4, right? Of course, my favorite matrix, inverse. Okay? So this is going to be literally an inverse function, like from algebra 1 or 2. Right? So this is the thing that does 1, 2, 3, 4. Cool? All right. So your trick is you write down your matrix 1, 2, 3, 4. Okay? Then augment this thing by the identity matrix. Okay. Now, fiddle until what? Good. Until the identity switches sides. You guys see that? So I'm going to pretend this is a augmented system. I'm going to try to solve it until I get the identity on this side. Once I'm to the point where I have 1, 0, 0, 1 on this side, the stuff that's over here is going to be, don't worry about what it is right now, but the stuff that I get over here is going to be the inverse. Cool?
Yes.
All right, so I'm going to make this happen. And it doesn't matter which way you do this, okay? So as long as what you're doing is valid row operations, you can pick and choose those operations and it'll be totally fine. Cool? All right, so how am I going to set out to try to get the identity matrix on the left-hand side? What's the first thing I should target? Probably that 3, right? So same thing as solving an augmented system, except you have to deal with 2 things on the right-hand side. So I'm going to take that first row, and I'm going to multiply by -3. I'm just going to write it down here. So -3, -6, -3, 0. Then I'm going to rewrite my system, except now it's not a system, right? It's kind of a double system. What do I have in the top row?
The same.
Exact same thing, don't fiddle it around. 1, 2, 1, 0. In the bottom row, what am I going to have?
0, -2, -3, 1.
Okay, cool. Now what?
Now you want to multiply by. Just wait a second.
Subtract the bottom row from the top row.
Close.
Divide the bottom row by 3.
That would work.
Yeah, let's do that.
I'm not going to do that because I have an easy thing right now.
I mean, half the bottom and the top.
Yeah, let's just add the bottom and the top together.
Yeah.
You guys all see that? If I add the bottom and the top together, what's going to happen?
Yeah.
You're now 1.
I'm going to have 1, 0, 0 number. Okay? And that'll be fine, and then I'll divide through and figure out how to make this a 1. Cool with that?
If you add the top and bottom together.
Right. So, what am I going to do the bottom row? Nothing. 0, -2, -3, 1 on the bottom row. On the top row, what do I get? 1, 0,
-2, 1.
-2, 1. Perfect. Now what?
Now you play right. Yeah.
Negative 2.
Okay, I want to take this second row, right? I need to see a 1 here, right? So, what am I going to do to top row? Nothing. And the bottom row? 0, 1, right? I'm multiplying by -1/2. So,
No.
positive 3/2 and -1/2. Okay? So, the inverse matrix I was trying to calculate is what?
That.
Yeah, that. The right-hand side of that. So the right-hand side in there is -2, 1, 3/2, -1/2. Boom, done. Okay, what does that mean?
That is
That's
your,
the inverse function.
Yeah, that's
that
the
is
inverse
your
function.
undo function.
So there's some kind of blob. Going one way, we do 1, 2, 3, 4. Right?
If you plug x, y into the left side.
Mm-hmm. So this takes x, y vectors, right, over here. Turns them into some kind of zw vector. Some other 2 vector, right? And then if I want to get back from a zw vector, I can perfect apply this function. So that -2, 1, 3/2, -1/2. That's the way you back out. You guys see this? This is kind of the idea of dividing. So if I thought about what that statement means, that means if I take 1, 2, 3, 4, multiply by an xy, I get zw, yeah? If I wanted to solve for xy, right? You guys see this? I've got an equation that says ax is z. If I wanted to solve this, I would like to divide by a, right? This is a function though. You can't divide by it. You have to apply its inverse. You guys see that?
Function is a series of operations.
Yes. Yeah.
You're saying the whole thing's a function,
The whole thing's a function.
but it's a group of functions.
No,
Why are you saying it's a function?
because it's one function.
But what about your vertical line test? If you have multiple x values and you plug in one x value and get multiple y values, and it's not a function.
No. The vertical line test is weird here. Because the vertical line test has to happen on the graph.
Uh-huh.
The graph of this thing is 2-dimensional input by 2-dimensional output.
Okay, thank you.
So it's a vertical plane test. And it works fine. That's a bit confusing, but basically the idea is, does this thing smash stuff? And the determinant tells me if it smashes things. Okay?
Wonderful.
So the determinant being 0 will cause it to fail the vertical whatever test. Cool? Questions, things? Don't sweat it too much if that last bit went over your head. It's a function from someplace to someplace else. And this is the unfunction from the range back to the domain. Cool?